Hello everyone, I'm doing problem 2 from chapter 9. He's asking for the network in kilojoule per kilogram of air. He's asking for the thermal efficiency of the cycle, and he's asking for the mean effect pressure in kilopascal. First of all, let's do a model engineering. We can say that it's a closed system, is written here, and the compressor and the expansion pressures are adiabatic, and all the processes are entirely reversible, and the air model is idle gas, and the kinetic and potential energy is can be like negligible. So first of all, let's determine T in each state, the temperature in each state. So let's find T in state 1. So from the diagram we can tell that state 1 T1 is equal to 300 Kelvin, and it's giving it the question. So let's do right now state 2, which is we can use this equation to find T2 based on what we are giving in the question. Okay, -1, this equation. We know that from table 20, K is equal to 1.4. So we plug this in this equation. So it's going to be T2 equal 9 over 1.4 -1 multiplied by, this is T here, T1 multiplied by 300. We'll get for T2 equal 722.47 Kelvin. Now we're gonna I'm gonna do new page, and I'm gonna solve. I'm gonna state 3 actually. So in state 3 we have to use the energy balance equation to find the T. So we know that M equal M multiplied by U3 negative U2 equal heat transfer 2 to 3 negative work 2 to 3. We know this is 0 because it's a closed system. So rewrite this to Q 3 to 3 equal M P T3 negative T3 negative T2. Solving for T3, it's gonna give us T3 equal to Q23 over M all over CV plus T2. Plugging all the number in there, we'll get T3 equal to 1350 kilojoule over kilogram over 0.718 kilojoule over kilogram K plus 722.5 K, and that will give us T3 equal to 26027 Kelvin. So we state T1 and T2 and T3 we're missing, T in state T4. In state 4, we go to state 4 right now, and we found T4, which is gonna be using this equation phi3 over phi2 all k negative 1 multiplied by T3. So T4 is gonna equal 1 over 4, 1.4, 1 over 9 actually, negative 1 multiplied by 260.2.7, which is equal to 1080.8 Kelvin. So right now we state all the temperature in the fourth state. Right now, after we find all the temperature in each state, we can right now solve for what he's asking for. Let's start with A, the network, and the equation for that is, it's gonna be work cycle equal Q cycle, and we can rewrite that to work cycle over mass flow rate, which is equal Q23 over M negative Q41 over M. That will give me Q23 over M negative CV T4 negative T1. Plugging all the numbers here, we'll get 1350 negative 0.718 multiplied by 108 0.8 negative 300. Putting this in calculator, we'll get the work cycle equal to 789.4 kilojoule over kilogram. Boxing my answer. Now we do B, which is asking for the thermal efficiency. We all know this equation, which is equal thermal efficiency equal to work cycle, but we just find out Q2 over 3. So this is gonna be the answer here, 789.4 kilojoule over kilogram over 1350. That will give me 0.585 multiplied by 100. The percentage, you will get 58.5%. This is the thermal efficiency. Now we're doing the last one, the last part, which is the main effect pressure is given, which is this equation is asking for work cycle over V1 negative V2. We can rewrite that to work cycle over M V1 negative V2. Rewrite it again to make it simple and clear, over M over V1 1 negative V2 over V1. It's all knowing except V1. So let's find V1 first, then we'll plug all knowing in the equation. So V1 is equal to RT over V1, and that will be 8.1, actually 314 over 28.91 kilojoule over kilojoule Okay, this is multiplied by 300 Kelvin, all divided by 100 kilopascal, and all multiplied by 1 over kilopascal, actually over 10 to power 3 nm. I'm trying here to confirm it to to millicube per kilogram. So I'm gonna multiply by 10 multiplied by m over kilojoule. So this is what cancel out. This is what cancel out. This one out. I'm gonna get v1 equal to 0.861. What I did here is making v1 with the meter cube over kilogram. Now we plug all the known in the equation of the mean efficiency, which is gonna be MEP equal 789.4 kilojoule over kilogram over 0.861 meter cube over kilogram multiplied by 1 negative 1 over 9 multiplied by 10 cube in m over kilojoule, as I did before, just trying to cancel out to make it in kilopascal, and multiply by kilopascal over 10.3 in over m cube. So this is what cancel out, this is what cancel out. We'll get MEB equal to 1031.4 kilopascal, and this is the answer for the mean efficient pressures. So we're missing D, which is the maximum temperature, which is gonna be T3, which is equal to 26027 Kelvin. Thank you so much. So we found all what he's asking for. We can graph it to see if the thermal efficiency will change or not. You can plot it, and that's it. Thank you so much for watching.